I know that I asked you to be on page 10 of your book. I'm not on that page, and you just need to be okay with that. Okay? We need to have some conversations, first of all, about these that you see up on the screen. Okay? These are basic parent functions. You saw all but one of them Monday and Tuesday when we talked about parent functions. So my first question is this. Do you recognize just by sight at least one of these parent functions right here? If you do, raise your hand. Do you recognize at least two of these by sight? If you do, keep your hand up. Do you recognize at least three of them by sight? Do you recognize all four of them by sight? Okay, put your hands down. Good. If I ask you to name the parent functions, could you name at least one? If you could name one parent function, put your hand up. If you could name two of the parent functions, put your hand up. If you could name three of the parent functions, put your hand up. Can you name all four of the parent functions? Okay, those of you who put your hands down between 3 and 4, which one can you not name? Just tell me a letter. Okay, 2 is not a letter. B, okay. You can't name B? Can anyone in the room name what parent function B is? This one right here. Anybody? Okay, beside Mr. Johnson and myself, is there anyone in the room that can name B? What? It is not linear, but that's a good guess. Because at least that's a parent function that we talked about, right? Okay? It absolutely is exponential. Good job. Okay? Yeah, if you read the words at the top, it does tell you some options. I was just trying to see if you could do it without seeing that. That's okay. That's okay. All right? As we're traveling from the left to the right, what's happening to the value of the function? It's increasing, isn't it? It's growing. Is it increasing or growing the same amount every time you take a new step to the right? No, it's getting bigger faster as you go along, isn't it? Okay? That's kind of like the trademark of exponential functions. It's either growing really quickly or it's shrinking really quickly. All right? So now that we have that one out of the way, can you name the other three? There were several of you who still had your hands up if I said, can you name 3 of them? So are these the 3 that you can name? Okay. Most people can name this one. What kind of function is this one? Quadratic. Okay, I'm so glad you said that, because this crazy kid earlier said, that's a parabola. What did I say? That's right. It is a parabola, isn't it? But what did I ask for? I asked for the type of function it was, right? While it is a parabola, what type of function is it? It is a quadratic. Does that make sense? Okay? So most people can name this one, and most people can even name this one right here. What's this one? So the problem is when people say linear, they want to tell me that this one is linear also because it's a line. So one of these is the linear parent function, and one of them is not the linear parent function. Can you tell me which one's which? Okay, so I don't know if you knew those words before or if you actually just looked at the top and could tell one of them has to be linear and one of them is constant. At this point, I don't care. I'm glad you know the words. Okay, but you are correct. This one is linear and this one is a constant. Okay, this one's linear because y equals x. So every time I went over 1, I went up 1. If I went over 2, I went up 2, since x and y are equal, since they're the same value. That's where we get this line that goes like this. This, while it is a line, is not the linear parent function because it's not y equals 6, it's y equals 1 or 2 or whatever the scale on this graph is. I think it's 1, so it's y equals 1. Because any x value that I choose, it doesn't matter how far left or right I go, I always go up 1. So that's a constant because there's no variable involved, is there? Okay? So are you okay with those first of all? Alright, so you guys are actually on page 10, right? Where I told you to be. And on page 10, there's a box, which you knew to look for because of what we talked about the other day. There's a box that says Core Concept. Okay? In our core concept, it tells us specifically what 4 functions we're going to be dealing with in this particular lesson. Okay, what's our goal for the day, by the way? What's our objective for today? Explore transformations, okay? You did the transformations in Algebra 1. How many different types of transformations are there? Like 7 or 8 or 5 or something like that? Obviously, I've counted, right? There's more than just 1 or 2. But what I need you to understand is that we're going to kind of start slow with transformations, not because they're hard, but because they're a big deal. Okay? We do them very often throughout the year. So I want us to get a good firm basis of this, so as we go throughout the year, it just gets easier and easier for us. Okay? So today, we're only going to be dealing with 2 kinds of transformations, and I'll tell you what those are in just a moment. But these are going to be the main parent functions that we deal with in this unit, because these are the 4 that you're most familiar with. Yeah, we could talk about logarithmic, yeah, we could talk about rational or cubic, but those are pretty new to us. Okay, so we're going to stay with stuff we're familiar with a constant, with linear, with absolute value, and with quadratic. Okay, now their equations are written right here for you. So if you need to refer back to what is the actual parent function of, or equation of the parent function, you can look back. Okay. Also, the domain in the domain in the range and the graphs are written here for you as well. So this is a really good place to refer back to if you need to. All right. So the 2 types of transformations that we're going to talk about today. Please take out your vocabulary page. Remember, you should have a vocabulary page. It says vocabulary at the top, like this. And I think so far your vocabulary page should say set builder notation with some words out to the side, and it should say interval notation with some words or some examples out to the side, right? So today we're going to add 2 things to this page. The 2 type of transformations that we're going to deal with today. Don't write that yet. I wrote the wrong word. Sorry. Vertical shift and reflection. Those are the 2 types of transformations that we're going to deal with today. Okay? Just for the record, my goal for you today, for our class, is to do the warm-up, check your homework, go all the way through the lesson. You have time to do all your homework, and then the bell rings. That's my goal. Okay? And the only class who hasn't gotten all the way done wanted to talk a lot during the period. Just chitter chatter. So I was having to shush people and get them back on focus and stuff like that. Okay? So don't be one of those classes. Let's get all the way through so you don't have homework this weekend. Fair enough? Okay. So let's talk about these a little bit. Have you ever seen a mirror? I know that's a silly question. You've seen mirrors before, right? Seriously. Vertical shift. Let's talk about this. This is really important. Really, 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 really important. That when we're talking about vertical shifts and you write this word, you have to remember your F. That's really, really important. Don't leave your F off. Because if I leave my F off, it is a different word. Okay? I could show you some examples from last year. I won't because I'm recording it right now. But I could show you an example from last year where I asked a question, and when the student wrote their answer, they forgot their F in their answer. Okay? I get the fact that a vertical shift that we leave off the F of, everybody does that when we sit on the toilet to go, right? But when we start talking about horizontal shifts, that's just very strange. Okay? Very strange. So let's really remember our F's. Work on that. Okay? It's important. So we're talking about a vertical shift and a reflection today. All right? Now, before we go talking about vertical shift and reflection, I wanted you to have those down in your paper so we can refer back to that in a moment. The first thing we're going to do in our lesson is we're going to talk about family functions or function families. Okay? Have any of you guys ever seen my daughter? What does she look like? She looks like me, right? She's my little mini me. And some of you have even seen my husband and my son. What does my son look like compared to my husband? He looks like my husband, right? Okay. So does it make sense that if I have a parent function, that I might have a family function or a function family? Would that make sense? Now, for the record, we do not have a mother function. We don't. So we probably don't even need to talk about mother functions because that's really close to something else. Okay? We don't need to get in trouble with that. Fair enough? Okay. So I'm going to say to you, let's look at this graph right here. If we're looking at this graph, this is not a parent function graph. And I know that because it's not at the origin or even close to the origin or something like that. But could you tell me what parent function this graph came from? Yes or no? What does it look like then? Tell me what it looks like if you can't remember the name. So what does the graph look like? The graph looks like a V. So you knew that that graph and this graph were related, probably in the same family, because they both look like V's. Okay? For the record, it's called absolute value. Okay? Now, some people remember it's called absolute value because it looks like a V. So absolute value looks like a V. Maybe that will help. I don't know. Okay? But if you looked at the one right underneath it, is that absolute value? What's that one? That one's quadratic, isn't it? Because it's whooshier. It's like a rounder, not roundish, no? What does it look like? It looks like a parabola, doesn't it? Okay? So we would say that's probably in the quadratic family. Does that make sense? So if I gave you any of the main four functions that we're talking about, these four, if I gave you any function that looked like one of those, could you associate it with a family or with the parent function? Okay, good. So that's the first goal for today. All right? Now we need to talk about this. Now notice this is on page 11 of your book. You can't really tell on the screen, but this one is black and this one is blue. Okay? They made them two different colors on purpose. This is the parent function. It labels it for you. It tells you it's the parent function. And then there's this function right here. And here's its equation. First thing I want to talk to you about is this, and making sure you understand. This one's called f of x, and this one's called g of x. Why? What if I said, hey, girl, go get the door? Am I talking to this girl or that girl or that girl or that girl? I'm not pointing to him. You don't know which one I'm talking about, right? Because I just said a general statement. But if I said, hey, Madison, would you please go get the door? Everybody would know who I was talking to, wouldn't you? Okay? So the reason I call this F and this G is just so I can keep them separate and so it's clear which one I'm talking about. Fair enough? Okay. So if this is my parent function, how does the blue line relate or compare to my parent function? It's lower. Okay? Now, is there a correct math word for that, or is it perfectly fine for him to say it's lower? It's lower is fine. Okay? It is lower. Now, we know, hopefully, we can look at our vocabulary sheet and be able to tell we're probably not going to say it's lower. What are we going to say? We're going to say there was a vertical shift. And in this particular case, from our parent function to our new function, it was a vertical shift down. There's two ways to tell how far it went down. Any ideas? So we could look at the equation first of all, and we can see it says -4. What's the other way? Yeah, I could count, right? Count on the graph. 1, 2, 3, 4. It went down 4. Now, just for the record, with linear functions, that can get tricky sometimes because of the slope that's involved. It acts just a little bit different than all the other functions. So a safe place to look to find about the vertical shift is the equation. If you have it, it's the safe place to look. Okay? Any questions about this? Guys, would this work for any other of the main functions that we're talking about? Could I say f of x equals x squared and g of x is x squared minus 2? And could you tell me if there was a vertical shift or not, first of all? So you're saying yes, there's a vertical shift. And where is it moving? Down 2. Does that make sense? So if we're talking vertical, isn't that 2 separate directions? What directions are we talking about if we're talking about vertical? Down and up. So this moves it down. Could you make an educated guess what would move it up? Maybe a plus sign, right? Does that make sense? Does that seem logical? So if we have f of x equals like the absolute value of x, and g of x being absolute value of x plus 5, would that move it up 5? So that would be a vertical shift up 5, right? According to our objective for the day, what are we supposed to be talking about? Transformations. Have I said that word yet? No? So let me make sure that you understand what I'm talking about. Has anyone ever heard of Optimus Prime? Yes? Okay. So what is he? So he's a transformer, the leader of the Autobots. But like, what is he like on a normal basis? He's a semi-truck, right? With a face on the side. Like, the Autobot symbol on the side. I'm sorry. Okay. But when there's danger or when someone needs his help, what does he do? What does he become? A giant good guy robot, right? He's a giant good guy robot. Was there one time where he was bad? When he left Earth? Oh. So he was tricking them to think he was bad, but he was really not bad. Oh. Sam. Sam was mad? Because they all left. Okay. Like hidden? They were there, but hidden the whole time? Okay. Nice. Absolutely. Okay. So, just for the record though, most of the time, or I guess all the time, Optimus Prime is a good guy. Oh, when he's alive, right? Because sometimes he dies? Okay, he died. All right. But now he's back. I don't want to spoil it for anyone. I'm sorry. Okay. Okay, back on track. Back with me. Back on track. When he's a semi-truck, and then there's danger, and then suddenly he's a giant robot, good guy, what happens in between there? He transforms. So he roll out, right? He rolls out. So what does he do to get from a semi-truck to a giant robot? Don't say transforms again. What does he do? He changes, right? He changes from a semi-truck to a giant robot, good guy, right? Okay? So hopefully that whole conversation has helped you realize that the word transformation means change, right? It doesn't mean Optimus Prime, it means change. Okay? Transformations means a change. Now, it's not a specific kind of change. It's not just one type of change that can happen. There's several. Okay? And like I told you earlier, we're going to talk about 2 of those today. The first being a vertical shift, and the second being a reflection. Okay? We already kind of talked about reflection. We'll talk about it here in a minute so I can make sure you understand what's happening to the equations when the reflection is happening. But for now, how are you feeling about a vertical shift? That's a type of transformation. If I gave you an equation like this, could you tell me, number one, if there was a vertical shift and what kind of vertical shift it was? Yes? Good. So, on your vocabulary page, right here, remember sometimes we'll write a definition and sometimes we'll just give ourselves examples to refer back to? Okay? So on the vertical shift, let's go ahead and write f of x equals x squared. And f of x equals x squared plus 5. What are we going to write if I ask you to compare these two functions, or compare this function, let's call it g instead, compare g of x to f of x, which is the parent? What would you write? Vertical shift up 5. Vertical shift up 5. Okay? Any questions about that? Got it? Okay. So look right down here then. Here's my parent function, happens to be a quadratic. Here's my parent function. What's happening with this blue function? It's flipped, and our math word would be a reflection, right? Okay. What is it reflecting over? The x-axis, right? There was confusion earlier because somebody thought this was a y. But that's okay. That's okay. No judgment, right? Okay? But it is an arrow for the record. Okay? This is an x-axis. Our function is reflecting over the x-axis. So tell me what you see. You've already told me what you see in the graphs. Tell me what you see in the equation. Where? Where is there a negative? It's out in front of that parent function form, right? Okay? So if I said to you, back on your vocabulary page, if I said to you that f of x equals the absolute value of x, what would g of x have to look like for it to be a reflection of the parent? Negative and then the absolute value of x. Does that make sense? Yes or no? Okay. So if I said to you, compare g of x to its parent, which is f of x, what would you write? A reflection over the x-axis. Now, is the x-axis the only thing we can reflect stuff over? No, but that's where we're starting. Fair enough? That's where we're starting. Okay? So on the next page, actually next page after that, we have some example problems to look at. The directions on 3, 4, 5, and 6 say identify the function family. So let's do that first. Identify the function family to which each function belongs. So can somebody tell me the function family for 3? Absolute value, okay? Somebody else tell me the function family for 4. Quadratic. Anybody agree with that? So earlier they weren't sure because it was this way. Why is it the same thing? Why is it so quadratic? Because it's just a reflection. It's just transformed. Good job. Okay? So somebody else besides those two tell me what family this is from. Linear. And somebody else besides those tell me about this one. Constant. Excellent. Okay? Now, remember that today all we're talking about is a vertical shift or a reflection. So we're going to kind of not exactly follow. I mean, we're comparing, but we're only comparing vertical shifts or reflections. So does this graph right here have, number 3, have a vertical shift? By how much? So he said vertical shift down 8. Does anyone agree with him? Several nodders. Okay. Can I tell you what they said earlier? They said vertical shift down 4. Because of that right there. When we're moving absolute value or a quadratic, what are we kind of focused on? What's our anchor point? It's the vertex, isn't it? So the vertex is where we go to look to see if there's any vertical shift or anything like that, right? Now, I totally understood what they were thinking because earlier when we looked at the line on this page over here, you remember this? When we looked at this line right here, didn't we look at the x-intercept? How far did it go from here to here? Yeah, so I didn't make myself clear enough, so I want to make sure I'm being clear enough with you right now. Okay, so when we're talking about absolute value or quadratic, it's that vertex that we are focusing in on to look at transformations. Okay, so you can tell, I know there's a horizontal shift, we're not worried about that right now, but there was clearly a vertical shift down 8. Is there any other way that you can tell that it went down 8? Yeah, look at the equation, look right here. It's outside of that general form. It's outside all by itself, down 8. Fair enough? What about number 4? Is there a vertical shift? Tell me 2 ways you can tell. It's 3 higher from the origin. Good. And it says plus 3 in the equation. Excellent. Is there anything going on else with number 4 that we need to focus on? There is a reflection, isn't it? It's opening down this time instead of opening up like its parent does. Okay? Any questions? So what about number 5? Number 5, I'm showing it to you on purpose because remember I told you sometimes how lines can be tricky? This is one of those places. Okay? Look at the graph. Where does it cross the y-axis? Notice that it's counting by 2s. Oh, excuse me, the y-axis. Thank you. X-axis is still counting by 1s. Oh, y-axis is counting by 5s, isn't it? Sorry. I missed that. Thank you for fixing it. Where is the y-intercept? Well, on a graph like this, it's really hard to tell, isn't it? Because it's not in an exact spot. It's not at an intersection of these little line things. So this is one place that would really need to look at the equation to tell how far down. Does that make sense? Okay, good. What about the constant? Is that a vertical shift? Where did it used to be? At 1. And now it's 2 higher at 3. Any questions about this? All right, this is your lucky day because Mr. Johnson and I have a present for you. It is a present. Even when you leave this class, you can keep it because it's a present. It's called a student journal. And look at the front of it. Aw, it's the same as your textbook. How sweet. On page 10 of your workbook. Hey, could anybody tell that the homework tonight was not in the book, but it was in the workbook? Okay, because it says workbook. Okay, I just want to make sure I was being clear about that. Okay, it does say workbook. So page 10, which is the page I'm on right now, you're going to do problems 1 through 7. Okay? Now what I want you to keep in mind is that we're going to follow most of the directions. You need to identify the family function to which it belongs. And you need to compare the graph of f to the graph of its parent function. But we're only talking about vertical shifts and reflections. So those are the 2 things that you need to keep in mind. So very quickly, everyone look at with me at number 3. If we're looking at number 3, what's the first thing we need to say? We need to say it's absolute value, and we need to say that there's no vertical shift, because there's no vertical shift. And that's all you have to say on number 3. I hope you have a wonderful day and a great weekend.